This is the unit circle. It's a circle, and you can think of it as a graph. It'll help make it easier when we figure out these points right here around the circle where they are. And the reason why it's called a unit circle is because from right here to right here, it's 1 unit. And a circle can be measured in degrees or radians. Let's start right here, for example. So this, from there all the way around, it's 360 degrees, or 2 pi radians. If you want to go the other way, it can be negative 2 pi radians, or negative 360 degrees. Let's start by figuring out the degree. A circle has 360 degrees, so all the way around here, it would be 360 degrees, or 2 pi radians. So we'll do the radians next. So
half of 360 degrees is 180, and then you can take half of that, that's 90, and then half of that is 45. And you figure out what's half of 90 and add it on to 90 to figure out that one, and add half of 90 and figure out 180, and then half of 90 and figure out 225, and then half of 80 find out 270, and so on and so on. So that's degrees. And
for radians, you figure out, so all this way around, counterclockwise, would be 2 pi radians. So half that would be pi, and half that would be pi over 2, and then half that, etc., etc., and then you can figure them all out.
I have filled in all the points already to make it easier, and I'm going to walk you through how to solve how I know that this is one of the points. So if I go down, that will be, this is 90 degrees, because it went straight down, and so this is a special triangle because it's a 30, 60, 90. So this part from here to here, that's 60 degrees. Okay, so now that we know that that's 60 degrees, that looks like that's 60 degree, 90 degree. So this thing must be a 30 degree. But I don't really need to know that to solve it. So now I know that this thing is equal to 1, this side right here. And so 2 times x is equal to 1. What's happened? So that's equal to 1/2. So this side must be 1/2. And this side must be the square root of 3 over 2. So because it's 1/2 over, that means that x value is 1/2. It's 1/2 over on the x-axis. The x value is 1/2. And because on the y-axis it's at the square root of 3 over 2, that's what's in the y value. So first let's draw a thing down again to help us out. So again, this is a 90-degree angle. This from here to here is 45 degrees, and this is 1 unit long, this thing right there. So we know that it is a 45, 90-degree triangle. That's what it's looking like. So we can use this thing right here, this special triangle. So 45, so this would be the square root of 2 times what is equal to the 1. So I did some calculations on my calculator, and I figured out that it is square root of 2 over 2, and right here it's also, because both of these sides is x, so this would also be square root of 2 over 2. So that's how far it is over on the x-axis, so that's the x value, and that's how far it is on the y value. And there's a reason why I color-coded this way, and we'll get to it later in the video. So this one we have to drag that bar down again. This one is 30 degrees, and this one's 1 unit long. So it looks like a special triangle. This one, like it is this triangle, this special triangle. That means that this has to be 60 degrees. Okay, so now we have that this is a special triangle. We know that that's 1. It's similar for this one, except for we're just going to switch it around, the x and y values, because we know that that's 1. And so that's 1 is equal to 2x. What's 2x times what? 2 times what is equal to 1? That's 1/2. So we know that this part 1 right here is 1/2. And the square root of 3 times x, since x is 1/2, the square root of 3 over 2. Okay, so it's on the x-axis, it's gone over square root of 3 over 2. So we put that there, and it's gone up on the y-axis, y 1/2. Now we have that part done. Okay, so now we're pretty much done with the special triangles, except for we got to go over the Pythagorean theorem. Okay, so the Pythagorean theorem also is a way of figuring it out. So if we knew that this is I'll just give you an example right here. We're just going to do this problem again. So, we know that this is 1, and we know that this is 1/2. So we know that if I were to do the Pythagorean theorem, let's do it up here. It's a squared plus b squared equals c squared. So, and a squared is the hypotenuse. So it's 1/2 squared equal to 1x. Just say 1 squared is equal to that plus x plus, let's say, c squared. So you gotta plug that into your calculator. 1 squared is equal to 1/2 squared plus, let's just use x because it's easier in this program. So, hey, look at what we got. It's equal to square root of 3 over 2. And check this out. That means that this side is square root of 3 over 2. Does that fit in with that point? It totally does. It's a way to check your work. Okay. Now, we got to go over sine, cosine, and tangent, and I'm going to explain how these over here are similar to these. Okay, so you can, let's get rid of this one, the special triangle. Okay. Now, since this is, remember how I told you to think of it as a graph? Now, if it's going to help. So, you have the x-axis and the y-axis. So, if you want to go to, say, if you move to the other side of the x-axis, that means that x would be negative and y would be positive. Oh, I just found an error here. This is not equal to negative 1/2. It's equal to just 1/2. So, let's fix that. That error. Okay, so, now because it is the x-axis, it's along the x-axis, it's negative to the x value. So, you're on the negative side of the x-axis, but it's still on the positive side to the y-axis. So, y is always going to be positive, and the x side is always going to be negative on this quadrant. On this quadrant, you're in negative land, as Jameson would say. So, both of them are going to be negative because you're in the negative x side of the graph and the negative y side of the graph. Here, you're just on the negative y side of the graph. You're on the positive y side of the graph. So, because right here is the origin and it's 0, 0. Okay, now, the reason why they're similar is because this matches up with this. And this matches up with this. And this matches up with this. They all match up because it's the same. If you look, the one across from it, 180 degrees, should be the same, but just different. You go find the point, and you go the one that's 180 degrees away from it, it's going to be the same point, except for it's going to be different negativities. Because across from this, it's negative, negative, because you're in negative land. And the same thing for here, because you're in negative land. If you go 45 degrees over, it's also going to be, is that 45 degrees? No, that's 60 degrees. If you're 60 degrees over, it's going to be similar. It's going to be related to the red one. Remember when I told you that these were color-coded for a reason? That's why. Same thing with these. The one opposite of it, it's different, same point, different negativity on each of them. Different negativity, different negativity. This one, different negativity. All of them have different negativity. Even the black ones have different negativity. Okay, so now that we have that one done, now it's time for the next part of the video where I'm gonna show you how to do trigonometric functions.
Okay, so to calculate this, use this point using trigonometric functions, you can use this little hint. All students take calculus. This means you can use sine, cosine, tangent. This one only sine. This one only tangent, and this quadrant only cosine. Okay, so we're gonna do an example and try and get. Okay, so we're gonna try and find this angle right here, and we're gonna call it theta. Okay, so first, we are going to use the we're going to look at this and we're going to say, okay, so we've already figured out that this, we know that this is 1 because it's a unit circle. And this right here is 1/2 because that's for the y value. This one is 1/2. And this one is square root of 3/2. And we can do it with this, knowing this, we can use it all those different ways. We can do it all these different ways. So why don't we pick, cosine, for example. Okay, so cosine of theta would be equal to the adjacent, which is adjacent to that. It's 1/2 over what? Hypotenuse, 1. So cosine of that would be equal to, I've already calculated out, that's equal to 45 degrees. So that's equals to 45 degrees. So it's perfect. We've confirmed that it's a special triangle.